All right, so picking up from our last lecture, our last snippet, what we're going to do now is recognize that we've almost got the two equations that we need. But before we can proceed, we're going to go back and make a further assumption. The last equation that is equation 4, so recall equation 4 from last time, is actually the one that we want. We want this equation. However, in order to make things simpler for us, we're going to assume the following, that the function p of t is equal to 1. Okay? So in other words, we are going to go back and start working with the following differential equation, which would be y double prime plus q of t, okay, times y prime plus r of t, okay, times y equals g of t. So you can see how this naturally comes out of that assumption. Now, there's a couple observations we need to make. If the coefficient of the second derivative isn't 1, we divide it out so that it becomes 1. Okay, I'll repeat that. If the coefficient, this right here, the coefficient of the second derivative isn't the number 1, we divide it out so that it becomes 1. In other words, this is the form that we're after, including that number 1 next to the second derivative. Okay. Now, the formula that we're going to be getting will assume this, so it's very important that we keep this in mind. So now upon doing this, the two equations that we want to solve for the unknown functions are given by the following. They are u prime sub 1, y sub 1, okay, plus u2 prime, okay, y2 equals 0. I'll call this equation 5. And u prime 1 times y prime 1, okay, plus u2 prime times y2 prime, and that's going to equal g of t. And I will call this equation 6. Okay. Note that in this system, we know the two solutions, and so the only two solutions here are u prime 1 and u prime 2. Okay. So solving the system is actually quite simple. First, we solve for equation 5 for u prime 1 and plug this into equation 6 to do some simplification. So first, note that we can do the following. U prime 1 equals negative u2 prime times y2, all divided by y1. Okay, so this is equation 7. You could probably see that it comes from equation 5 up above after doing some simplification. And we're going to plug this into equation 6. So this is going to be plugged into equation 6. You can guess where. And then we're going to do some simplification to solve for u prime 2. So let's do that. So plugging in, we get the following. We get negative u prime 2, which it looks like a u, y2, okay, divided by y1, multiplied by y prime 1 plus u prime 2 times y2 prime equals g of t. Right? Okay. So next, what this implies is that we have u prime 2 multiplied by y prime 2, okay, minus y2, that's a y, multiplied by y prime 1, okay, divided by y1, just like that. And this all equals g of t. Okay. So we're not done yet. There's a few more steps we can do. So from above, this implies that we have u prime 2, okay, multiplied by, oh, let's see, right, this can be y1, y prime 2 minus y2 times y1 prime, just like that, all divided by y1. All right. And this is going to equal g of t. So you can guess what the next step is going to be. We're going to solve for u prime 2. So u prime 2 is going to equal y1 times g of t, okay, divided by y1, y prime 2, okay, minus y of 2 times y prime 1, okay? And this is equation 8 for our reference. All right. So make sure you note down equation 8. That'll prove to be very important later on. So we now have an expression for u prime 2. We just derived that. So now what we can do is plug this into equation 7, and that will give us an actual explicit expression for u prime 1. Although we had it before, it was not fully defined because we did not have u prime 2 defined. Now we have u prime 2 defined, so now we can get u prime 1. So let me go ahead and recall what equation 7 was, just so it's easy to reference. Remember, this was u prime 2 times y2. This was equation 7 over y1. So now we can plug in equation 8 to solve for u prime 1. And that'll give us equation 9. So what this implies then is we have u prime 1, and that's going to equal negative. After you do the algebra, it's going to be y2 times g of t, all divided by y1, y prime 2, like this, minus y2 times y prime 1, just like that. Okay, and this will be equation 9. And that is the equation that's going to be very nice, along with equation 8. So equation 8 and equation 9 are both going to be very, very useful. Now, this next one will not come as a surprise, but I will say you've been preparing for this next step for quite a long time. So what do you do with all this, right? This is what you're going to do. First, I want you to notice something. Notice the following. What you're going to notice is that I'm going to take the Wronskian, okay? And my input will be y1 and y2 for the Wronskian, okay? And this has to be the situation where we have y1 times y prime 2, okay, minus y2 times y prime 1, okay? And remember that this needs to be a fundamental set of solutions, so this value can't equal 0, right? So again, recalling that y1 of t and y2 of t are a fundamental set of solutions, so we know that the Wronskian won't be 0. So this is a clear result from this fact. Now we're going to use this to our advantage as well as we keep going on. So this is where the Wronskian becomes very, very important for us. Okay. And also, I want you to realize there's one additional step we can do. All we need to do now is actually integrate equation 8 and equation 9 in order to determine what the actual function u1 of t and u of 2t are. So doing this gives us the following. u1 of t equals negative integral, and that's going to be y2 times g of t, okay, divided by, can you guess what it's going to be? The Wronskian of y1, y2 dt. For fun, you should go back to equation 8 and see that the denominator is in fact the Wronskian. Okay, and for u2, for equation 9, this will be the integral, it's positive, and this will be y1 times g of t divided by, you guessed it, the Wronskian of y1, y2 dt. Okay? So provided we can do these two integrals right here, and this is a big if, a particular solution to the differential equation is given by the following. Okay, and this will conclude our third video. It will be y, capital P of t, equals y1, u1 plus y2, u2. Okay, or more generally, this is going to equal negative y1 times the integral of y2 g of t, okay, divided by the Wronskian of y1, y2 with respect to t, and this is going to be added to y2 times the integral of y1 g of t, okay, divided by the Wronskian of y1 and y2, all with respect to t. Okay, so stay tuned for the next video. We'll summarize the properties for this particular solution and also go further in analyzing this method for the variation of parameters.